All right, Algebra 2, we have just about made it. We are at the last lesson, Unit 5.2, and so now we're going to look at solving radical equations. All right, so just like with the rationals, the fractions, we can't divide by 0. All right, so remember, you can't take a number and divide it by 0. 5 divided by 0 doesn't exist. All right, if you try to put it in your calculator, you get an error message. Well, with radicals, we have excluded values also. And that's on square roots only that you have to worry about that, because in square roots you can't do the square root of a negative number. We work with imaginary numbers, but with these, when we're solving, we're not looking for any kind of imaginary numbers. We're only looking for values that are real. All right, so if we end up with an answer where we get the square root of a negative number, then we would say there's no real solution. All right, now with cube roots, you can take cube roots of negative numbers. That's okay. So back to our rational exponents, x to the 1/2. Again, that fractional exponent is the same as the square root of x, and just like the x to the 1/3 power is the same as the cube root of x, and so on. So what we want to do is first practice substituting numbers in and then simplifying them to see if the left side is equal to the right side. So we're checking to see if the given value for x is a solution to the problem. So on A, the square root of x minus 2 equals 6, we're checking to see if x equals 38 or not. So if you plug 38 in for x, you can check really quick. All right, so 38 minus 2, we're checking to see does that equal 6. Well, 38 minus 2 is 36. And the square root of 36 does equal 6. So yeah, 38 is a solution to the problem. B, so now we're checking to see is 4 a solution. So if we take 4 and plug it in, so 1 plus the cube root of 4 minus 4, we're checking to see does that equal 2. Well, 4 minus 4 is 0, and the cube root of 0 is 0, and 0 plus 1 is 1. So the question is, does 1 equal 2? Well, no, it doesn't, so they're not the same. So no, 4 is not a solution. Then we can check to see is -5 a solution. All right, so here we have 2 times. Now when we substitute numbers in, especially negatives, use parentheses. Okay, we're checking to see does that equal 8. All right, so -5 squared is positive 25, and 25 minus 9 is 16. So 2 times the square root of 16, does that equal 8? Well, the square root of 16 is 4, and 4 times 2 is 8, so yeah. All right, -5 is a solution. All right, so when we're solving radical equations, here's basically our steps. We want to isolate the radical. Then we want to square or cube, depending on what we have, both sides of the equation. And we'll solve for x or whatever variables in the problem. Then we have to check for false solutions. So we want to check to make sure that they actually work. And you really only have to check on the square root problems, not the cube root. All right, so let's do this number 2. So we have to isolate the radical. So we have that square root of x minus 3, and then the plus 4 is on the outside, but it's on the same side as the radical. So we want to isolate the radical. So we're going to subtract 4 over first. So the square root of x minus 3 is equal to 9 minus 4 is 5. Now we can square both sides. Right, so when we square a square root, they cancel each other out. So we just have x minus 3 equals 5 squared is 25, and we can add 3 over. And we get x equals 28. So this is where we take that x equals 28 and we plug it back in for x and see does it work. Well, 28 minus 3 is 25. Square root of 25 is 5. And 5 plus 4 is 9. So yeah, it does work. All right, number 3. So we have to isolate the radical. That 2 is on the outside, so is the negative. So we're going to first go ahead and subtract the 2 over. we have that negative in front. Cube root x plus 1 equals 2. Make sure you bring that cube root down. Got to get rid of that negative, so we're going to divide by -1 on both sides. Right, so now we have the cube root of x plus 1 equals -2. So now we're going to cube both sides. So when we cube a cube root, they cancel each other out because they're called inverse operations. And then -2 cubed is -2 times -2 times -2, so that's -8. Subtract the 1 over. So we get x equals -9. All right, so again, we take that -9 and we could substitute it in and check. -9 plus 1 is -8. The cube root of -8 is -2. And then 2 minus -2 is the same as 2 plus 2. That's 4. So yeah, it does work. All right, number 4. All right, x plus 4 to the half. Remember a half, that means the same as square root. So I'm just going to change it. It looks a little easier. So subtract the 1 over. All right, then I'll square both sides because it's a square root problem. -1 squared is -1 times -1, which is +1. Subtract the 4 over. All right, so -3. So again, I got to check and make sure it works. I'm going to plug it into this one right here because it has the square root, just easier to work with. All right, so -3 plus 4 is 1. The square root of 1 is 1. And then 1 plus 1 is 2. And 2 does not equal 0. All right, so check again so you can see why it doesn't work. Okay, so this is no solution. All right, so again, substitute that -3 in, and the left side will not equal the right side if you do that. All right, number 5. So this kind of a problem is we have radicals on both sides of the equation. So there's 2 radicals in the problem. So here, all we have to do is we're going to square both sides. All right, so if I square this side and square this side, the square and the square roots again cancel each other out. So all that's left is what's inside both radicals. And now I can just solve it as normal. All right, so x equals 16, and then I could check it real quick and make sure that it works. So 2 times 16 is 32, and 32 plus 3 is 35, so I get 35 under the first radical. And then I want to check, do I get 35 under this one? So 3 times 16. So 3 times 16 is 48, and then 48 minus 13, that's 35. Okay, so I do get the same thing. So yes, that does work. All right, and then 6, here I have cube roots. So here I'm going to cube both sides. And so I get x equals 2x minus 6. Let's subtract the 2x. Divide by -1. Right. Now I want to check again. So I get cube root of 6 on the left side, and then I plug it into this one. 2 times 6 is 12, and 12 minus 6 is 6. I get the cube root of 6 on the right side, so it does work. All right, and then this is the last kind, equation type number 3. This is when you have a radical on one side, and then there's a variable on the other side. All right, so again, we want to isolate our radicals first, get them by themselves. So I'm going to change this 4x to the 1/3 into a radical. So this is the cube root of 4x. And now I'm going to cube both sides. So I get x to the 3rd equals, so this is going to cancel out. I just get 4x. All right, so what I have to do is get everything on the left side, because you can't just divide by x. You're not allowed to do that. But you can subtract the 4x over, get them on the same side. Subtract 4x. Can't combine them because they're unlike terms. But by putting them on the same side, I can use factoring. All right, so I'm going to go back and factor this. So I can pull a GCF out, which is x. I'm left with x squared minus 4. Squared minus 4. All right. Now from there, if you want to, set them equal to 0 and solve, or you can continue to factor. X squared minus 4 is x plus 2x minus 2. Difference of squares. Now set each of those equal to 0 and solve. So we get x equals 0, x equals negative 2, and x equals positive 2. All right? And then, again, if you were to plug them back in, because this is a cube root problem, it does work. All right, number 8. All right, so I'm going to change this to a radical. Square root of x plus 1 plus 5. I'm going to isolate the radical, so I'm going to subtract the 5 over. So x minus 5. Okay, you can't combine them. That's not the same as like negative 5x. It's x minus 5. All right, the radical's by itself, so now I'm going to square both sides. So when I square the left side, I have to be careful because that's a binomial. The whole thing has to be squared. So I'm going to put parentheses around it. So x minus 5 squared, you want to rewrite it as x minus 5, x minus 5. And then the right side is just x plus 1. All right, now x minus 5, x minus 5, you actually have to multiply or double distribute this problem out. All right, it's not x squared plus 25. It actually ends up being a trinomial. All right, so make sure you double distribute over x squared minus 5x, and then distribute the negative 5 equals, and then x plus 1. Now we want to combine like terms. So this is our trinomial that we're going to get. All right, so now what we're going to do is move everything from the right side to the left side, and that's because there's an x squared in the problem, and most of the times when there's an x squared in the problem, you have to use factoring to solve it, and you can't factor unless it's equal to 0. So I'm going to go ahead and subtract the x, and subtract the 1. So x squared minus 11x plus 24. So now I can use my x, because it's trinomial. So two numbers that multiply to 24 that add to negative 11, negative 8, and negative 3. So now I'm going to set each of those equal to 0 and solve it. I'm going to get 8 and 3. All right, now, this is a square root problem, and so we have to be careful because with square root problems, again, it's possible they don't work. One of them could work, both of them could work, none of them could work. So we have to check each one. So where we're going to check it in at is at the original problem, but basically this step's right there. All right, so where I changed it from a fractional exponent into a radical, it's just easy. So I'm going to plug in each of those numbers and see does the left side equal the right side. So I'm going to plug 8 in first, just so you can see. All right, so I'll do it down here so you can see the work. So 8 equals square root 8 plus 1 plus 5. So I want to see does the left side equal the right side. So I get 8 equals square root of, that's the square root of 9, and that's 3, and that's 8. So yes, they do work. All right, so 8 works. So now I want to check to see does 3 work. So now I'll plug 3 in. 3 equals 3 plus 1 plus 5. All right, so 3 plus 1 is 4. Square root of 4 is 2. 2 plus 5 is 7. So you can see that 3 and 7 are not equal. So that means that 3 is not a solution. Okay, it's like an extraneous solution, excluded value kind of thing. So 8 is the only solution. So even though we found 2 solutions, only one of them actually is a solution. So you have to be careful with those. All right, and then let's do this last one. So this one, the radical's already by itself. So we just square both sides. All right, so again, we have that binomial x minus 8, so we want to write it twice, just like the other one. And we're going to double distribute. Okay, double distribute. Again, this will get us a trinomial after we combine like terms. Combine like terms. All right, so we have that x squared in the problem, so we're going to subtract the x over and subtract the 4, so we can get 0 on the right side. Minus 17x plus 60. All right, so here's our trinomial, and we are going to use the x for factoring. So two numbers that multiply is 60 but add to negative 17. So it's going to be negative 12 and negative 5. Right, and we solve it, we get x equals positive 12 and x equals 5. All right, so again, we have to check to see if both of them work. Again, we're going to take it and plug it back into, we're going to go back to this original because it has the square root also already in for us. So plug it back into the original problem, and we'll check to see if they work. All right, so I'll plug 12 in first. So does 12 minus 8 equals the square root of 12 plus 4? So that's the question. Well, 12 minus 8 we know is 4. 12 plus 4 is 16, and the square root of 16 is 4. So 12 works. So now we're going to check 5. All right, so does 5 minus 8 equal 5 plus 4? Square root. Well, 5 minus 8 is negative 3. Does that equal the square root of, well, 5 plus 4 is 9. Square root of 9 is 3. Does 3 equal negative 3? No, they're not the same. So that means that 5 does not work. Only 12 does. All right, so a lot of these times when you get two solutions, one of them is going to work and the other one's not. So just be careful with those square root problems. All right, that is it.